meltwater pulse 1A. It's a much more constrained record. It really shows that the magnitude of this abrupt sea level rise was, almost certainly more than 10 meters, and it might have been even up to 20 meters, a little bit around 14,500 years ago. This is a record from Tahiti. So basically, the discussion, and it kind of traces back to another very well-known paper by Peter Clark from 2002, where this fingerprint theory was used on the few records that actually had this meltwater pulse 1A, different parts of the world. And by comparing them, it would be possible to infer what the main source of ice melt would be. And this fingerprint work has really strongly favored Antarctica as the most likely source because it produced a pattern that was most consistent with the observations. But of course, there was another camp that vigorously opposed that idea and claimed, no, it has to be the Laurentide ice sheet for all kinds of reasons. And I'll show you one, which is certainly not proof, but it's very intriguing. This is a study, and I'll show you a little animation here. This is a basically combined ice sheet climate model study. So basically, climate drives the melt of the Laurentide ice sheet along with the Cordilleran ice sheet here and the Greenland ice sheet. And basically what to look for is this meltwater flux through time. So we're going to start at the last glacial maximum, and we're basically going to run all the way through the last deglaciation. And the fascinating thing here is we're going to reach this huge peak here. So just pay attention to what happens here on the map when we approach this peak. And it basically refers to the keyword up here, and that is the collapse of the saddle between this ice sheet and this one. When that happens, you increase the amount of ice melt by a huge amount. And a very neat thing is that we have a second collapse that happens that produces this peak. And what's really neat, this is really spontaneously generated by the model, so it's not really very tightly constrained by anything. This corresponds actually very nicely to that 8.2 event I talked about earlier. I'll play it one more time so you can have another look. So we have a long period with pretty steady melt, and then at some point we reach this huge peak. The timing is really off relative to that meltwater pulse 1A, but that's really not a major issue, I think. So it certainly shows a viable mechanism. And of course, if this is true, then the Laurentide / Cordilleran could be a major source of meltwater pulse 1A. The reason I show this is that the short story is if we can better constrain what happened during the early Holocene, that will indirectly give us more information about what might have happened around meltwater pulse 1A. Because if meltwater pulse 1A was primarily driven by Antarctica, most Antarctic melt would have happened around that time, and relatively little would happen later on, and vice versa. So with some luck, we will be able to say something about this as well. So just to kind of wrap up with some very general comments. One thing I maybe didn't mention explicitly, but I think what this work shows is that if you want to push these high-resolution sea level records further back into the early Holocene and perhaps even beyond, working in a large delta is incredibly beneficial because those are the rare settings where you have had sediment progradation out into the ocean, and you can actually access these older records while you're still on land, right? In most places, you have to go well offshore if you want to find anything related to the early Holocene or prior to that. So it's a big logistical advantage. So the sea level jump that we observed allowed us to really connect it in a pretty tight way to that final Lake Agassiz drainage. And our estimate is that we're looking at a magnitude of globally average sea level rise somewhere in this range during that time, which basically requires that there must have been a significant contribution of just ice melt, as in addition to that fresh water from the lake that drained immediately. And this is, of course, a little bit more speculative, but I hope I've convinced you with our work around the 8.2 that this sea level fingerprint theory is viable. Of course, when I show this to people like Jerry Mitrovica, he looks at me and he said, like, well, Isaac Newton already told us this, so what's new? So it's admittedly, it's a rather complicated way to confirm Newton's theory of gravitation, but for me, it's still reassuring to see that it actually works. So, and it gives me some hope that we may be able to better constrain the source of meltwater during the early Holocene with this evolving sea level record that I just showed. And with that, it's time for me to stop, and I'll be happy to answer questions.